Hello, everyone, and welcome to this session. On behalf of Environmental and Waste Management Group, I would like to open this session. My name is Olga Kuzmina. I will be behind the scene and will be helping our presenters to answering the questions that they receive from you. If you have any questions, please pop them in the Q&A chat, not in the chat, in the Q&A session. The topic of today's webinar is International Challenge with the Electrical Vehicle EV Batteries Recycling Process. And this session is co-hosted with Hayden Davis, who is the Editor-in-Chief at ATF Professional and Auto Recycling Board. Hayden, the word to you.
Hi, Olga. How are you? Can you see me just to make sure that
yes, I can
working?
see you. I can hear you well.
Okay, and thank you very much for your introduction. And also thank you very much to IOSH for giving us the opportunity today to be able to raise awareness within the vehicle recycling industry. And also thank you to everybody who's attending, who's showing interest in, sorry, my 3-year-old's just walked into my kitchen as if on cue, sorry. So thank you for everyone who's just, who's tuning in today just to find out more about the challenges that we have when it comes to health and safety within our yards. To introduce myself, I'm Hayden Davis. I'm the editor of Auto Recycling World, which looks at news and information about vehicle recycling and on a global scale. And we also have a sister web platform called ATF Professional, which focuses on the UK industry. So the reason we're working with IOSH today is to be talking about the health and safety in ATS, which is in the UK we call ATS means authorized treatment facilities. And we are, as an industry, we are in a transition. We're an old industry. We've been around for 100 years. We've had health and safety has always been paramount within our industry. But as we are now looking at the traditional ICE vehicles coming into our yards, we are also now seeing electric vehicles start to come into our yards, which is starting to present some new challenges, and having to think about how we overcome them. But so today's two parts. So we have representatives from EMR and Salvage Wire talking about the present and the very fast approaching future. So I'd like to start to introduce our first speakers. And if we can just ask everybody, we have a very short time for questions at the end. So if you can be asking the questions as the speakers are making their presentations, it will really help us speed up and get through as many questions at the end. So I'd like to introduce Roy Johnson and Danny Swygart from EMR. They're both IOSH members themselves. So if you guys would like to come on board, and then let's start the first presentation. Hi guys.
Thanks Hayden, and good afternoon everybody. So I'm Danny Swygart. I'm the Regional Safety, Health and Environmental Manager for EMR, and we're going to kick off the presentation. So to start with, a little bit about EMR. It's a company that I've worked for 30 years. And our overall purpose is to be a global leader in sustainable materials. It's a family-owned business, a very large business with over 2 billion turnover, but it's still a family business with no shareholders. It's just one family that owns the company, and they're one of the world's biggest metal recyclers. Being a family business, we do things in a certain way, the EMR way. So we care for our people, for our customers, for our workplaces, and for the communities in which we operate. And we do solutions, not problems. We try to do what we agreed and take the right long-term decisions for the future. We don't always get it right, but that's what we strive to do. And we try to do this without wasting time or money, and with humility and humour. So we're also your local recycler with 60+ depots across the UK. And of those 60 depots, the majority of those can accept end-of-life vehicles, cars that have come to the end of their life for processing. And when we process those ELVs, depollute them at 50 of those sites across the UK. Also, we've recently entered a big commitment to try to achieve net zero carbon emissions by 2040. This is so it's a very big commitment and objective that the family and owners of the business take very seriously indeed. The roadmap of how to get there is not clear as yet, but we shall work it out. And we've kicked that off last year with our decade of action in 2020 through to 2030, where we're working on 4 main pillars in our sustainability strategy, focusing on energy productivity, renewable electricity, which we already use. 90% of our electrical energy comes from renewable sources already, so we're well on the way with that objective. Movement of people and material handling and movement, and we're looking to replace all of our equipment over time with either fully electric or hybrid vehicles, plant and equipment. So I'm going to hand over to Roy. That's a bit about EMR. I'm going to hand over to Roy now for the main part of the presentation, focusing on some of the top hazards in end-of-life vehicle depollution. So we could go on and speak about many hazards and risks that are involved in this process, but the time we've got is quite short, so we're just going to focus on the top 5, and then moving on later, as Hayden said, to Andy to talk about the future and electric vehicle depollution. So over to you, Roy.
Thanks, Danny. Thank you very much, everybody. Good afternoon. My name is Roy Johnson. I'm recently new to EMR. I started in February 2021, just at probably the peak of the lockdown, so interesting times for me. I'm also one of the SHE managers here at EMR for safety, health and environmental, and I look after the Alex Dock estates and transport nationally. So we are looking for us at the 5 topics that we look at within EMR as being some of the hazards that we're dealing with. Obviously, as we all know, and as you guys know, there's potentially more out there, but we are constricted on time. So we will crack on and get through this as professionally and as quickly as we possibly can. Thanks, Danny. So one of the biggest topics, and it's renowned throughout our industry, is the risk of fire. And the risk of fire obviously starts from the fire triangle. Well, we have the sources of fuel because we're decanting from the cars, taking the fuel from the cars and then putting them into our fuel farm. We also have non-standard items that come in with the vehicles, which, as we can all know, we've got quite a few tales to tell of what's been found within them. And our fuels get extracted and are pushed out to the fuel tanks, which have bunded tanks, explosive-proof bunded tanks, so actually help and support us with the risk of what we're actually doing. The sources of ignition, because we're actually in a deserated zone, we try to mitigate this as much as we possibly can. So batteries are actually removed before they go into this area, as you can well expect. However, because we actually start looking as to the locations within the cars and searching, you'd be surprised as where batteries can be found in unexpected locations, hence the dedicated search of our operatives. We decant the fuels from using the spike versus the drill, which is a bit controversial now. We have people turning around saying, what do they prefer? Do they prefer to use the drill or do they prefer to use the spike? Each of them have got their advantages, although some people are now turning around saying that using the spike actually puts a dent in the tank, and then there's still a residue of fuel that potentially could be left behind. So we have got to be mindful of that, and as we go ahead and go through with this changing of resources, we have to make sure that the equipment that we're using is actually right for the role that we're doing. So the handling of vehicles, one of the biggest problems we have is the ergonomics. We've got to make sure that our operatives are looked after in every stage of this process. So we have vehicle stands, which actually assists with the ergonomics of our operatives on where they're standing, how they're standing, and how they're actually moving about once the vehicle is up on the stand. The stands are fixed to the floor, so this removes the risks of vehicles falling off them. And we have mechanical aids as well for removing the cats, something that we can discuss further on down for this presentation. The forklift trucks that we use are the ones that have got the long forks that actually go right underneath the actual vehicle and comes out at the other side, thus maintaining the stability of the vehicle on the forks as it's being lifted and moved around the yards. Obviously, safety, as we all know, is paramount, particularly in yards that can be quite congested. So the forklift truck driven in reverse so the person can see where they're going, making sure there's no sharp braking and moving around that potentially could rock the car and potentially put the car out off the forklift truck onto the floor. We also advise our drivers that they do not lift the car above their head height to try and move around other obstacles, because again, taking the car at this height, we also have the potential whilst they're driving to actually lose the stability of the vehicle. So the manual handling as well, the aspects that we have is within our EMR sites, we make sure that the wheels and the batteries are taken off at floor level, just removing the problems potentially around ergonomics, and then making sure that the batteries are removed before they go into the depollution side, and keeping them out of the way of any sources of explosive atmospheres. So the batteries and the wheels are off before they actually go onto the stands for the next part of the pollution process. The slips, trips and falls, again, because of the environment that we're in, oils on the floor, poor housekeeping, sees operatives skating around if they're not careful in what they're doing. Within EMR, we have basically a clean as you go policy. So all the oils are drained into the proper drainage systems. Any oils that spill onto the floor are cleaned up, as we got the clean as you go. We also have the grates on the floor as well, so the spills can literally go through the standing grates that the guys stand on and onto the floor, and then they are lifted and drained at the end of the day. We also have a good housekeeping policy, and everybody is encouraged that once they've used a tool, they actually put it back on the boards where they have actually got it from. Now, what we're actually doing within EMR is we are standardizing our tool boards. So we're going to have shadow boards. Some sites have got these, other sites you will see them appearing if you are an EMR customer. And the shadow boards will be aligned with all the tools that the guys will be using through the day. Between quarter of an hour and half an hour prior to the end of their shift, the shadow boards are then checked, all the tools are returned and placed back on the boards, and a general housekeeping around the floor area, mopping up spills, making sure the tools are all away, is then looked after, and then it's clear and ready for the following day. So the use of tools, quite a debate within our industry, I think, with regards to the use of tools. A lot of people like to use the tools that they find in the back of the cars as opposed to using the tools that we're actually providing for them, which is a challenge for us in itself. However, we use hand tools and power tools. We have to deal with corroded items, which we have, again, use the right tools for the right job. There's no point in trying to get something off a car that is corroded and they're using pliers, or they're not using the right spanners to loosen or remove the actual nuts out of the way for them. So we ensure that all our operatives are given the right tools to do the job. The power tools in which we use, like most of us, air tools and hydraulic power tools, particularly in the zoned areas. Approved processes for power tools that are used outside the zone areas, because again, power tools are actually used on sites as well in some locations, but these are used well away from the depolluting areas so that we have no concerns of actually bringing in a source of ignition into a potential disease area. So the cat cutters that we use, there is at the moment a combination of two. We have the hydraulic cat cutters that seems to be quite popular, and we're now having to trial the battery operated cat cutters. So one or two sites have actually brought these in and actually turned around and saying that these are actually better for us to use. And again, these bring in additional challenges to us from an ergonomics point of view, but also from a maintenance point of view as well. Particularly with the cat cutters, if the blades get blunt or start going blunt, they have a tendency to twist. So the operative will put the cat cutter up to the cat and obviously operate the button, and the cat cutter itself will twist. So it's not actually cutting through the exhaust, it's actually twisting it, and it actually has an effect ergonomically on the operative to actually keep hold of the weight of the cat cutter and also ensure that the cat is secured to the cat catcher, so we don't have any issues with regards to the cat striking the operative once it actually cuts through. So again, the maintenance of the actual cat cutters is important, and the operatives are aware of when they can feel the cat cutter twisting, that it's time for the blades to be looked at and changed. The manifold cats, as we all know, some of them can't be cut using the cat cutter because they are cast, and therefore they will shatter. And one of the other issues that we've had in the past is the actual locations of the cats. And hopefully, as we've seen and going forward with the modifications of cars and going more and more over to electrics, this is going to be eradicated, not in the short term, but hopefully long term. But again, we've also had insights with car manufacturers in the designs of vehicles going forward, and how it would actually help and support, particularly on where the cats are situated. But that brings up other issues that we've seen in the press with regards to cats being removed without authorization, which is obviously not very good at all. So the environmental releases for ourselves, and also for everybody really, to be fair, the EA do pay us a visit, as with all of our people or industries that's dealing with removing of depolluted cars at the end of their lives. And we have an obligation to make sure that this is done correctly. So for the F-gas, with regards to the depollution of the cars, all our operatives are given the test gauge to ensure that the actual gas within the air conditioning units has been depleted. It will register if it hasn't been depleted. Our operatives will then remove the gas from the car, and this has to be recorded for the environmental agency. So should they pay us a visit, then we can actually demonstrate that we're actually depolluting the vehicles as per the recommendations, and that we can actually inform them and show them the documentation that this information is actually factually correct. With regards to removing the VOCs, the volatile organic compounds, as we know, the petrol from the vehicles, these all go to the vents, to control tanks which are vented. So any buildup of pressure within the tanks will vent, but they're not on site for that long periods of time. We're fully aware of the risks, particularly to fire and catastrophic events with the explosions in relations to bunded pallets, bunded tanks with this type of resource of material in it. So our fuel tanks are taken and drained very regular with authorised, approved removers from site. And the RCFs from the cats themselves, refractory ceramic fibres. Our process is quite quick. Once the cat has been removed from the car, it is cling film wrapped around the cat, and the cat then is put into the bag, again ready for waiting to be removed from site. Our concerns as well with probably most of our people within this industry is the release to water and land with the fluids that we have within the sites. We have quite a robust environmental plan on all our ELV sites. All our staff are trained in spills and spills emergencies. So the bulk fluids are stored in tanks for recycling and are removed from site on a very regular basis. So we do not have excessive fluids stored on any of our sites. We certainly have spill control measures. All our operatives are trained in spills kits, how to react in a spills on site and how to clean it up. We also make sure that there is drainage covers to prevent the fluid from going into the drains, and we have interceptors on site to prevent it from getting into watercourses. In the event of anything like this happening, the full emergency procedures are implemented and operations are stopped until the actual event has been dealt with and cleaned up properly. So moving on and moving into the future, we have had a few high voltage cars coming through the yards. As it's natural progression, there's a lot of electric cars now out on the roads, and unfortunately, like any other vehicle, they are prone to being involved into accidents. So the risks that we're facing now, and what we're actually doing as a company, is we're actually training and certifying all our staff so that we can have evidence that they are technically competent to deal with these types of vehicles. The tools we've found now are changing because we're dealing with the batteries. We're not dealing with commercial or normal, what we call everyday cars. So the tools are now becoming specialised as well. And we've noticed that, and that is being changed. So there'll be separate notice boards, separate shadow boards for these specific tools, and also separate rigs. The rigs also are going to have to be changed because the batteries are not in the locations where we think that they're going to be. I've seen two now being depolluted. One was under the back seat of a car, one was actually underneath the car itself. So will it be safe for us to pick the car up with a forklift truck as we do conventionally? We won't know. As the process changes and develops, then our practices is going to change and develops moving forward. Fire, new extinguishing materials potentially will have to be brought in, and also new procedures when dealing with a fire with an electric vehicle. We've all seen the catastrophic fires we've seen with lithium-ion batteries. We've not seen these go up as yet, and we do not want to see these go up. We want to make sure that we can depollute them properly, but make sure we've got the right fire precautions in place should the situation deteriorate. Chemical safety as well is something that's new that we're going to be looking into with the toxic combustible products, i.e. fire, and what effect that's going to have on us, and potentially how it would be undertaken to actually extinguish this. And we'll be working very closely, as we do now, with the local fire and rescue service. Our fire and rescue services are absolutely brilliant. Locally, they actually come onto site, they go through the emergency procedures with staff. We actually do emergency fire hose training with the local fire and rescue service as well. So it actually helps them that we actually know what it is that we're doing prior to them getting on site, and then they can provide us then with the technical expertise that they bring with them. So fluids, whilst we're not looking at petrol to be depolluting from these cars, we still have windscreen wash, we still have cooling systems, and potentially the shock absorbers as well. All with fluids, all still need to be drained. So it's a work in progress for us, and Andy's going to allude to this in the next session as we move forward. So in summary for us, and where we are as an EMR perspective, is we assess the hazards. We look at everything that potentially can go wrong, could go wrong, and throw in quite a few what-if scenarios, which really drives everybody bad, but we have to do it. We're trying to design out the risks where possible and make sure that everybody's included in this. There's nothing worse than trying to implement something when we haven't actually had the intervention from the operatives who we're actually expecting to go through with these processes. The training and procedures follow that, as we know. And again, training and procedures also need to be encapsulating the individuals that we're actually asking to undertake these tasks and these roles, because they're the best ones to actually get that information from. And then we can adapt our training processes to actually feel the needs of what they need as opposed to what we think they need. And of course, the PPE is, as always, is our last resort. And it's something that myself and Danny alluded to, that you don't see Lewis Hamilton going out in shorts and t-shirt, or we don't see our operatives going out in shorts and t-shirt either. And they actually wear the Nomax fire retardant overalls, so they are fully protected in the event that anybody has a flashover or a potential fire. So we are just as good as Lewis Hamilton in Formula 1. Thank you.
Hi guys, there was a lot of information there and really informative. And as you said at the beginning, as I was saying, you know, we're only just scratching the surface of the many hazards which can be found in a modern auto recycling yard. Yep. Okay. Sorry. So look, and we're going to go on to questions now. So I've just been looking at the questions that come through, and so Phil and Robert, if you don't mind, I'm going to leave those questions for Andy to answer, because he's more going to be focusing on the EV side with the questions you're asking. But Vince Howard has asked, how and where are you storing EV batteries? Those that are damaged and undamaged. How are you dealing with that?
So this is very much at the developmental stage at the moment. We've got a research and development department working in the West Midlands who are looking at how we're going to be processing electric vehicles, and they're currently looking at all aspects of that, including the storage of the vehicles. Currently, we have an outside contractor who will come in and remove electric batteries for us until we get our own systems up and running.
Okay, and also one of the questions I was going to ask is, you know, we have people from all over the world here today asking, and each country is on a different path as it invests more in vehicle recycling, as it sees the importance of vehicle recycling. And in some of the slides you had some mighty equipment there. You had the actual depollution stations. And Roy was talking about cutting tools and having the right tools for the job. How important is that to understand, you know, the most basic tools, you know, just not to be sort of just finding the nearest grinder or whatever? You know, how important is it to make sure, and what advice would you give to somebody who's, you know, sort of at the beginning of when it comes to recycling vehicles?
I think it's important, Hayden, that with regards to that, it's very easy to just pick up the first piece of tool that you've got, the spanner, the hammer, the grinding tool that you've got. You've got to be really focused on what it is you're trying to achieve and what it is potentially could go wrong if you've not got it right. There's many a time you see people using the wrong tool for the wrong job. Spanners that are being used when you've got full ratchet sets there. You know, we purchased the top quality equipment for these guys to actually operate with and to use with. So if it comes to the part that they're trying to take a cat off the vehicle when it's up on the ramp, and you see somebody going in there with a grinding disc, it's like, oh my God, you know, where are you? What are you doing? And what's actually out there? It's a case of asking people, you know, I'm sure if people come and approach us at EMR, we turn around and give them that support and that advice, because there's nothing worse than reading in the trade press, as you can appreciate, that somebody's done something that's led to an incident, an accident to an individual. That's the last thing we want.
And I think it's very important there, you said, come and ask, you know, sort of, sometimes there's so much machismo in this industry, so, but if you don't know, ask somebody, and there's no shame in that. And also investing in the right equipment just saves, you know, just not time, money and profit, but also could potentially save lives as well. And that's, I'm sure, as well, it is important.
We've been down that road, Hayden. We didn't get it all right to start with. We've been through all sorts of tools, and we've now identified what we believe are the right tools, but they are, you know, expensive but high quality tools for the job, and it's just it's not worth skimping on them. Okay, now we're very quickly on questions, so this could be the last one. This is from Patrick, who asks, what happens with removed pollutants from batteries? Is there assurance that these don't enter and pollute the natural environment? Very important question. So currently, obviously, if you talked about lead acid batteries, you know, we remove them, we put them into DOLABs, so proper battery plastic containers with lids on, store them under cover so they can't get any ingress of rainwater, and then they get collected and taken to a battery recycler. So we don't recycle the batteries ourselves, we remove them from the vehicles, put them in the correct storage, and then move them off to the experts who are going to recycle them correctly so they don't damage the environment. Electric batteries, I'll leave that one for Andy to cover. There's a lot of questions coming in about the EV, so we will be leaving those for Andy to be answering. I'm very conscious of the time. If anybody wants to ask any more questions directly to Roy and Danny, if you put them onto your Q&A,
I'm sure they can answer them as they go through them a bit later, so they can reply directly to you if you wish. But very informative, as you said, we just scratched the surface there. But I'd like to give a virtual round of applause to both of you. I know you've worked very hard for that presentation, very informative. So thank you very, very much. And thank you for your time.
No problem. Thank you.
Thank you. As Hayden told, please, if you can look through the Q&A and you see that you can answer the questions, there is a button type answer. Please, guys, you are very welcome to provide a typed answer, which will be recorded, and we will be able to then save it in the document and upload later together with your slides. Thank you very much.
Thank you. So, as we're seeing from the questions, there's lots of interest when it comes to EV vehicles. So let's move on and be looking at what we're going to be facing as vehicle recyclers in the future. So I'd like to pass the floor on to Andy Latham, who is from Salvage Wire. Andy, are you there?
I am here, yes.
Hi, Andy.
You can see me and hear me.
I can see you and hear you, so I presume everybody else can, which is great. I'm going to leave the floor to you. I know you'll be introducing yourself. As you can see, there's lots of interest here. You're going to have lots of questions. Hopefully, you might be answering these questions in your presentation yourself, but we'll leave it to you. And thank you very much.
Thank you, Hayden. Thank you very much, and good afternoon to everybody. Just a brief rundown. Salvage Wire is a unique automotive recycling consultancy, and we work with an enormous number of companies around the globe on high voltage vehicles, and we're working at one end with new manufacturers and research and development guys, and the recyclers and the salvage agents at the other end. So we bookend everything that we do. And today I'm short of time, and I know there's a lot of questions which we will get to hopefully either in the presentation or in the Q&A session at the end. So we've got to be fairly rapid through this and talk it through very, very quickly, and then get to the questions afterwards. Electric and hybrid vehicles, it doesn't matter what it is. It doesn't matter what the vehicle is. You have a DC, a direct current battery, and an AC, an alternating current motor. So whether you're looking at a 15-year-old Prius or a brand new Jaguar I-Pace, the battery is DC, the motor is AC. So you'll hear me talk a little bit about that during the course of the presentation. Now, this is around safety and around risks. So I'm going to focus very, very much on the safety and on the risks that are associated with electric and hybrid vehicles. And there's three main areas to focus on. Number one is chemical risks. Number two is electrical risks. And then number three is fire. So let's talk about chemical. All of these batteries at the moment have an electrolyte in them. The electrolyte in them is an alkaline electrolyte. Very, very different to the lead acid batteries that we've known for many, many years in the automotive industry. If this alkaline electrolyte is released from the battery because the battery is either mishandled or it's damaged in an incident, then even in very, very small quantities, that electrolyte is extremely harmful to health. So anything you do around these batteries, when you're handling these batteries, whether you're recovering vehicles, salvage, scrap, or anything of that nature, you must have the process in place, and you must also have the spill kits in place to deal with any of these batteries that may get damaged. Now, all of these batteries are basically multiple cells, and they're multiple cells connected together in series. And you can see here on the screen, you can see a module from a Toyota Prius. This is one module out of 28 that you will find in a Toyota Prius battery. In this particular module, there's 6 cells. And these 6 cells then join up with another module and another module and another module. On its own, this particular module is 7.2 volts. There's 28 modules in a Prius battery. Those of you who are good at maths can work out 7.2 volts times 28 gives you the voltage of that battery. And that's how they're made. That's how any battery is made. The configuration, the actual design of the cells might be slightly different, might be very different, but it is still multiple cells connected together in series. Now, if a battery does get damaged, 1 or 2 or half a dozen of those cells may leak electrolyte. But as I said, even in very small quantities, it is extremely dangerous. A nickel metal hydride battery has got potassium hydroxide in the electrolyte, and a lithium ion battery has got an alkaline electrolyte that I can never remember and I could not pronounce. But if that is released and it gets into moist air or gets into water, it will produce hydrofluoric acid, which even in very, very small quantities is extremely harmful to you if you get it onto your skin or you get it, breathe the fumes into your lungs. So chemical, very, very quick around chemical. Electrical risks are one of the most important parts of the safety and the requirements around these vehicles for handling these vehicles. The batteries in these vehicles can vary from about 144 volts to 800 volts DC. An electric shock of between 70 and 90 volts DC is all that's needed to stop somebody's heart from beating. DC power is a muscle contractor. So if it's in your hand, your muscles will lock and you cannot let go. As it travels through your body to get to Earth, it travels through your body and it hits your heart. Your heart is also a muscle and it stops your heart from beating. 70 to 90 volts and half an amp is all that's needed to stop your heart. The Renault Kangoo electric van is a 400 volt battery rated at 300 amps. So I think you can see why we take this a little bit seriously. The other electrical risk is electric arcing, which is where the electrical power will jump a gap. It will jump between 2 points, and that will ignite the air around you. And that ignition of air is extremely hot, and there's also some very, very noxious gases around that. Now, the risk within the automotive world, it's there, but it's reasonably low. For that reason, we strongly recommend everybody who goes through our training to wear full-length clothing, appropriate clothing as well, not man-made fibers, and to remove all metallic objects, rings, chains, studs, and things of that nature from their body, and remove them before you start working on the vehicles. The reason for that is that if an arc flash does occur, is that any metal on the outside of your skin will get burnt into your skin, and you don't want that to happen. People like me who wear glasses, we put a face mask on, and that protects us, and we can still wear glasses underneath that. Now, keeping us safe when we're working on these vehicles, we use PPE. Now, I know that Danny and Roy mentioned just now that PPE is their last resort with EMR, but with these vehicles, we have to. We've got to use personal protective equipment to keep ourselves safe. And the key personal protective equipment for somebody working on an electric or hybrid vehicle is an electrician's safety glove. Class 0, 1000 volt safety glove. Looks something like this. And every time you use one of these gloves or a pair of these gloves, okay, you have to check them and inspect them. Visually check them, make certain that they are undamaged, and then make certain that there's no little pinhole in the finger. Because if there is a leakage of electricity, the electricity will find the pinhole and it will go through your body. Now, many times I ask people when I'm doing big conferences, how would you check that there's no pinhole in here? And a lot of the responses that I get quite often is fill them with water. No, we do not want these gloves to be wet or moist. They really need to be dry. So the best way, the easiest way, is to get hold of the end, hold it tight, and then literally just spin them. And it traps air in, and you fold it over like that. And if it starts to deflate, you know there's a little pinhole here. Every time you use them, every single time, you have to do that. These gloves are class 0, 1000 volt. They are rated to protect your hands and stop you getting electrocuted when you're actually physically working on the vehicle and making the vehicle safe. The other thing we recommend as well is high voltage boots or rubber matting to stand on, which insulates you from earth, insulates you from ground, which means that the electricity cannot find earth, it cannot go through you. Now, people like EMR and other people who are going to be working on a lot of these vehicles, you can actually buy dielectric work boots, and they, proper work boots, polycarbonate toe caps rather than steel toe caps, which obviously might not be the best thing when you're dealing with high voltage electricity. And you can buy those and wear them. Or alternatively, rubber matting on the floor, or some overboots, some bright yellow, beautiful looking overboots that make you look a little bit like Ronald McDonald or Homer Simpson. And you put them over your standard work boots to keep you safe. PPE, it's essential. We can't get away from that PPE. And what's the process to make a vehicle safe? Well, it's quite detailed, and a lot of manufacturers differ. But the generic process is that you get to the vehicle, you shut the vehicle down, you remove the ignition key, you disconnect the 12-volt battery, and then you go find the manual service disconnect, otherwise known as the big orange plug. And you remove, you've got your PPE on at this point in time, and you remove that big orange plug. And what that does is that splits the battery circuit. That cuts the battery circuit in half. So there's no circuit, there's no power going around that circuit. And you remove that plug and you store that somewhere safe so people cannot reconnect it and put it back in. This plug could be anywhere in the vehicle. It could be underneath the boot floor. It could be underneath the back seat. It could be behind the back seat. It could be under the armrest between the two front seats. Fully electric vehicle, it might well be under a cover in the floor between the front and the rear seats. Or in the case of one vehicle that I know, it is underneath the vehicle. So, as I say, there could be anywhere and everywhere. Any vehicle recycler, any vehicle dismantler has got access through the European Union to the IDIS system, the International Dismantling Information System. And that is a free of charge service, which shows all the vehicle dismantlers and the recyclers the process on how to make a high voltage vehicle safe, and then also how to remove the high voltage battery. So recommend that anybody who is in the industry gets onto that iodis2.com and have a look at that. Once you've made the vehicle safe, once you've pulled the orange plug, you can then remove the high voltage battery. You still need your PPE, you still need your personal protective equipment, because the high voltage battery, we have not discharged the battery. The battery's still full of energy. All we've done is broken the circuit. So you still need that when you remove the high voltage battery. Once you've removed the high voltage battery, you've now removed the high voltage into, out of the vehicle, and the rest of the vehicle can be depolluted in the traditional way. Be aware as well, manual handling. Manual handling is important because these batteries are heavy. A Honda Civic Hybrid, an old Honda Civic Hybrid, the battery is about 23 kilos in weight. A Tesla battery is 600 kilos in weight. And batteries of other vehicles vary between that 23 kilos at the bottom and 600 kilos at the top. So manual handling is also an extremely important part of the work that we do on these vehicles. Now, fire. And I know there's been quite a few comments about fire. Yes, these vehicles can catch fire. It's debatable as to whether they catch fire more often or less often than conventional vehicles. But what is not in question is the fact that if these vehicles catch fire, the consequences can be absolutely devastating. The fire services, and I've done a lot of work with the fire services and the Fire Services College over the years, the fire services advise me that if an electric vehicle catches fire, they need 10,000 litres of water in 1 hour. That is, and the reason they need that is because first they've got to put the fire out, but then they've got to bring the temperature of the battery down. And by doing that, that reduces or eliminates the risk that the battery will reignite. When you've got a lithium ion battery, particularly, you have got the ultimate triangle. If that battery catches fire, we've got heat. We've got an ignition source because we've got sparks. And we've also got oxygen because the lithium ion cell will produce oxygen and it will self-perpetuate that fire. Remember what I said earlier, these batteries are multiple cells connected together in series. In a Tesla battery, you've got over 7,400 individual cells. So if one cell goes up, gets hot, the one next to it then goes up and gets hot, the one next to it, and so on. It's a chain reaction. And as I say, the fire services want that volume of water in a very, very short space of time. Also, these vehicles generate an enormous amount of pollutants in the smoke, these batteries, I should say. If they catch fire, there's an enormous amount of pollutants in the smoke. So you don't want to be close by to that as well. Now, the average fire truck carries about 1,200 litres of water. So to get 10,000 litres of water in an hour, you need a pump and a hydrant. Also, think about where that runoff is going to go. Where's the water going to go as it runs off the fire? Where is that going to happen? Where is that going to end up? So you really need to focus on that as well. There are alternatives out there. And one of the best alternatives I've seen and I've worked with for a number of years now is a vehicle fire blanket. And the vehicle fire blanket can be put over the vehicle and that cocoons the vehicle. It allows the fire to burn out inside underneath the blanket and it doesn't spread the fire to anything else. Because if you think about it, if one of these vehicles catches fire in your yard or catches fire in your workshop, by the time the fire brigade have arrived and by the time the fire brigade have set up their pump and their hydrant to basically put the fire out and then reduce the temperature of the battery, by the time they've done that, you now have a major incident. A vehicle fire blanket is a very, very quick, a very, very effective and very economical way of cocooning a fire and stopping that fire from spreading. The vehicle fire blanket is also reusable. Bridge Hill, who manufacture it, reckon that it can do 30 fires before you need to replace it. But I think if you've had 30 fires, I think you've got more of a problem. And the fire services have checked it, they've tested it, they've said it's brilliant. It's eco-friendly, it doesn't waste water, we don't have the water runoff, it stops all the smoke. It's really, really effective. But one fire service actually found a problem. One fire service said, disadvantage, we cannot practice traditional firefighting techniques with a fire blanket. Now, is that a problem? I don't really know. So I've briefly, very, very briefly, gone through some of the risks that are associated with these vehicles, the risks of chemical, the risks of electrical, the risk of fire. Much more detail is available, and what I'll do in a moment is I'll put some information on the chat and on the Q&A, some resources that people can actually go and look at so they can actually find out more about this stuff. Also about the PPE and the personal protective equipment and the tools and everything that you need that was mentioned earlier, and some resources on that. There's a discount code for you as well to save you some money as well. And I'll put all that up there on the chat, on the Q&A for people to see. There's also other resources. If people want to know more, then go on to Amazon, and there's a really, really good book by a gentleman by the name of Tom Denton, Electric and Hybrid Vehicles by Tom Denton. Have a look on Amazon for that. It's one of the best textbooks I have seen on electric and hybrid vehicles, and I'd strongly recommend that you get that as well. In summary, these vehicles we are going to see more of them. There is going to be more and more and more of these vehicles. Right now, we don't, there's a lot that we still do not understand. There's a lot that we're still working through. There's a lot that we're still trying to resolve issues on. We haven't had 130 years of working with electric vehicles. We've had 130 years of working with petrol and latterly diesel engine vehicles. We need to change our mindset. We need to change how we think. And as somebody said to me one time, well, you know, these electric vehicles, they're dangerous. Why have we got them? Well, let's put it in perspective. If we'd had 130 years of electric vehicles, I've got a good idea. Let's put a tank of flammable liquid underneath the back seat. Let's pipe it to the front. Let's inject it into a cylinder at high pressure, compress and explode it multiple times a second. We'd be looking at exactly the same sort of thing if the scenario was completely changed around. So this is something new. We will adapt. We will get better. We will know what's going on. Nothing, it's not perfect. We know that, but we are working towards that, and we are working to make it better. So I hope that's answered some of the questions that we've got. I'll now just hand back to Hayden while I just change my camera perspective, and we'll go back to questions and everything that has come up from that presentation. So Hayden, over to you.
Hi, thanks, Andy. Very thought-provoking, lots of good answers to questions already, which I'm sure a lot of people are already concerned about. But as always with you, you're always making people sort of to think again, what else are we thinking about? We've got lots of questions coming in. A lot of them are about recycling.
A quick comment. Sorry, Hayden, had to interrupt you.
Sorry.
So we were able to extend the session for about 5 minutes. However, I do not believe we will be able to answer all questions live. So we will collect the questions, and all attendees will receive a document with typed answers in once we ask our presenters to complete it. So please put all the questions in and they will be answered. Thank you. Hayden.
Hi, thanks, Olga. So as I was saying to everyone, so what we will do here is I think we need to focus on the safety. We're here to be talking about the safety, and then if we have some time to talk about recycling, the recycling of EV batteries, there's a lot of contention, there's a lot of thought and theory going out there. What I say to people is we do cover and we try to keep up to date with that topic on Auto Recycling World when it comes to EV batteries. So please check out that site and just see what articles we've already put out and to keep up to date. So anyway, Andy, back to some questions for you. Sorry, I just had to pop up on my screen. So Robert has asked about to catch fire, but I think you sort of covered that already about cars catching fire. And we have all seen the videos, but would you sort of say when you're in the yard, as long as you're following the right procedure, everything should be okay? You know, there's maybe a bit of scaremongering, but it's just being educated. Yeah, and we should be safe, but it's education and training is very, very important.
Yeah, education and training is critical around these vehicles, because as I said, you know, we've had 130 years of working with petrol and diesel. We haven't had 130 years of working with electric cars. So yes, it is a mindset, and a lot of people in my industry, in the industry I've worked in for 40 odd years, we've got a 12-volt brain. We know about 12 volt, we don't know about high voltage, and we've got to train and educate people around that. So yes, absolutely, completely agree with that.
Okay, so let's just move. I want to get through as many as possible. So Mark Connon has asked, what procedures do you have? And I think obviously you know, what procedures are there in place in the event of a Lithium-ion battery going into distress failure? Do you have a quarantine procedure and conduct thermal checks on the batteries? So how does that work?
Well, if we're talking about the vehicle salvage and the vehicle recycling industry, then you know, yes, some of them have put these quarantine areas in, but there's a lot that haven't, and there's a lot that need to actually reappraise the processes that they have. Having said that, if you've got an area where you can put the batteries or put the vehicle, put a blanket over it, then you don't have to quarantine to a certain extent. But there's a lot of education and an awareness that is required in the industry around these, you know, because people aren't doing that at the moment.
Is that because there's a lack of regulation? Do you think that will be sort of something in the future will happen?
I mean, you know, as part of the IMI, I know that that they've been pushing for a long time to get vehicle technicians accredited and trained, particularly with high voltage vehicles. And the government have pushed back on every opportunity. So I can't see them being any legislation in the near future.
And actually, the next question is going to come up from Emmanuel, which is good because Andy, I know you go all around the world giving this training out. So obviously you're speaking to people all the time. So Emmanuel asks, is there a globally accepted legal requirement regulating the use of electric vehicles? And does it override the environmental requirement of the country where the electric vehicle is being used? Have you come across that?
The only globally accepted electric vehicle protocol is the UN ECER 100 protocol, which actually specifies that these vehicles are high voltage when if the voltage is greater than 60 volts, hence why we have orange cables. So we have these orange cables because that indicates that the voltage is over 60 volts. It also specifies that there should be other things as well. So if the airbags deploy, the high voltage system should in theory shut down and things like that. But they, the manufacturers can't agree on a common plug to plug them in and charge them. And if you just look at some of the different plugs that I've got here around making these vehicles safe, they can't agree on a common plug for this either, or even a place for it. So that's the only globally accepted requirement on electric and hybrid vehicles. And that's just a guideline from the United Nations.
And Robert does go, I'm sorry, I'm going through these questions quite quickly, and some I'm missing out because it's more on the recycling side when we want to look at safety. Robert Natman does ask, so why is there no standardization of big orange switch? This would definitely be a big help. This is it. People
I wish.
Into the yard, they might have had some idea and they're not, and there's no standardization. So do you think this is going to happen? Do we need to let people know about this? Do we have to raise this awareness?
The problem is that we've now, the Toyota Prius came into production in 1998. And we've got these vehicles, we've got millions of these vehicles now being produced on an annual basis. And we've got no standardization at all. I can show you 3 different manufacturers with 3 different disconnection processes with 3 different types of plugs. And that's just 3. When I put everybody else in place, there's masses. So no, it would be lovely. It would be lovely, but they can't even agree on a common plug to charge for vehicles. So what hope have we got on something common to actually make them safe?
Would you say that sometimes as a public we are led to believe that EV vehicles are here, they're the future and everything's fine, but actually the reality is we are really at the beginning of this journey when it comes to dismantling these vehicles within our industry?
Very, very well. The whole recycling of these batteries, particularly the batteries, we're at the leading edge of this. We're still trying to work out what is going to happen. The majority of batteries, and I'll be honest, the majority of vehicles and the majority of batteries are lasting the lifetime of the vehicle and then some. So there is a big market that is now building around the second use of these batteries and the second use of these cells, and particularly the lithium-ion batteries as well. And Tesla recently announced that their batteries are good enough to do 1 million miles. Now, a car that's done 1 million miles is not going to be much good, but the battery still is. So what they're saying is that once the car's reached the end of its life, the battery then still has a lifetime as a life cycle and can do something else, be it in another vehicle, or actually even something down to second use storage for wind farms, solar farms, battery walls on your house, or something of that nature. So we could do 15, 20 years in a car, and they could do another 15, 20, maybe even 30 years as static storage before it needs to be recycled.
And that's going down to this sort of the reused, recycled, of what could be happening with the battery. And what springs to mind, I do know that there is a conference coming up in Geneva next month, the IBCR, done by ICM. So if anybody is more interested in the recycling reuse, you might want to check that out. So we're running out of time. So Vince Howard asks a practical question. He says, how would you store a damaged battery before it can be removed from site?
On that one, Vince, I would say it has to be stored in a a suitable location, batteries kept dry. You restrict the access to that location. So it's restricted access, and you do not ever mix the battery chemistries. So you don't store a lithium ion battery on the same shelf as a nickel metal hydride battery. I mean, I've seen various different processes, but one of the best was a container, and a container that's been racked out with shelves. You can drive a forklift or you know, a pallet truck or something like that in, put the battery in there, come out, lock the doors, and restrict the access to it. And that's the sort of thing that I've seen, and that works extremely well in this sort of scenario.
Cool. And Olga, please, I hope you're listening. Please interrupt us when our time is up. We're just going to keep on pushing forward, I think. Do we have time for one more question, Olga?
One more question, one last
One more.
question.
Oh, and there's so many what to choose from. I really want to go down the recycling route and reuse, but we're going to have another one. We're going to have to do maybe Auto Recycling World. We're going to do our own webinar,
yes,
specifically on recycling.
Definitely a topic.
And maybe if you can tell your once I've arranged that, if you can tell your members, and then they can join in, that'll be fine. So, Andy, the last question is there a way of discharging the EV battery prior to dismantling? We've got about 10 seconds.
Yes, it is there, but I wouldn't recommend it, because if you discharge the battery too low, if you take the discharge too far, the battery then becomes unstable and your fire risk has just gone up through the roof.
Okay, so look, thanks very much. There's a lot of interest in this. We have to take this further, but we're running out of time. I'd like to say a virtual clap, please, for Andy. You know, in the internet, does anybody hear you clap? I've never been able to get that answer. And also to Roy and Danny for bringing us up to date with what's happening at the moment. It's as an industry, it is very, very important that we get this right. And it's great to know that there's people dedicated to helping to make sure that people are staying safe in their yards around the world as we look into the future. Thank you very much. I will pass this over to Olga.
Thank you very much. We are going to run up now. Thank you very much. And you are going to receive a document with the Q&As. Recordings will be available on the website that I provided link in the chat. Thanks for being today with us. And as we can see, there is more interest, so we will explore it further. Thanks to our presenters. Thanks, Hayden. Have a lovely day, everyone.
Thank you. Bye-bye.